All right, question number 90 and 91. It wants us to find the standard deviation for the group data. And in question 91, find the standard deviation for the single data. Both of these are considered to be samples. So let's start off with 91 first. We're going to do question 91. Then we do 90 because 90 is a grouped frequency distribution and it requires more work. So to find the standard deviation, let's first understand what the standard deviation represents. The standard deviation is the approximated average between the data values x it is the average distance. So the average distance, I forgot the word distance between the data values, which we call x, and the mean, which we refer to as x bar. So a standard deviation is the approximate average of the distance between each data value and the mean. So to find the standard deviation, we need to find the average of the data values and the mean. But the word distance is important. Distance is positive. So distance is positive. Oops, I didn't write it correctly. Is positive. So sometimes when it comes to distance, right, you have to find a difference. And the difference can give you out a negative number. But distance itself is positive. So I'm going to just call you back to algebra real quick. And something that represents distance is known as the absolute value. And the absolute value is a piecewise function, but I'm not going to go down that route. But it equals to the square root of the value squared. You are squaring a value. Whenever you square a real number, it comes out as positive, whether if the real number is negative or positive. So when it comes to the standard deviation, right, it's going to be in a similar format to what we see here. The standard deviation, S, is equal to the square root of, well, remember, it is the average distance, right? So how do you find the average? Well, you divide by n number of values, and that means we have to find the sum of the difference between the data value and the mean. But because distance needs to be positive, and you cannot find the square root of a negative number and expect to get a real number out, we are going to square the differences. We call those the deviations. Now, we're almost done. So, we're talking about the standard deviation for a sample. The sample is smaller than the population, but we want the sample standard deviation to be a good representation of the population standard deviation. So here in our denominator, we're going to -1 from our sample size. So we can have a relatively similar standard deviation of the sample compared to the population. A smaller denominator means, in this case, more than likely the number is going to be larger than what it should be in the population. but we use that to kind of counteract the differences between the samples and the population. So we have to find our mean. How do we find the mean? Well, step one, to find the mean, you add up all the data values in the data set and then divide by the number of values. So we have 5 values in the data set, and we're going to add 2 plus 3 is 5, plus 4 is 9, plus 5 again, that's 15, that's 14, plus 6, that's 20. That's 20. 20 divided by 5 is 4. So our mean is 4. What is our next step? We found the mean. Now we need to find the difference between the sample data and the mean. The difference between each data value and its mean. 3, 4, 5, 6. So we're going to create a table with 3 columns. The second column is going to be x minus x bar. And we know that x bar is 4. So that's going to be the data values minus 4. So 2 minus 4, that's negative 2. 3 minus 4, that's negative 1. 4 minus 4 is 0. 5 minus 4 is 1. 6 minus 4 is 2. Now we're not done. Also, we're following kind of PEMDAS. We did the inside of the parentheses. Next is exponents. We're going to square each of those deviations. So square the deviations first before you add them. So negative 2 in parentheses squared. When you square a negative number, it comes out as positive. Square means you're multiplying the number by itself twice. Negative times a negative is a positive. Negative 1 squared is positive 1. 0 squared is 0. 1 squared is 1. And 2 squared, once again, is 4. Now we can find the sum of the deviation squared. Or the sum of the squared deviations, I should say it like that. So we're going to add up these values here. Add. And when you add it, that equals to 10. So this is step 2, I should say. Step 3 is now we're going to compute the standard deviation. So S is equal to the square root of 10 divided by, there are 5 data values, so 5 minus 1. Square root of 10 fourths. The square root of 10 fourths is the square root of 2.5. And before I go on, I do want to say something that I should have said earlier, but the value that is under the square root is known as the variance. So the variance in this case is 2.5. But this is not our final answer. Not final answer. Just saying it for reference. And then we take the square root of 2.5. I'm going to round to 2 numbers after the decimal. So that's going to be second, x squared, 2.5. And that is approximately 1.58. I don't know how the answer key may have it. It may have it rounded to 1 number after the decimal, so 1.6. Either one should suffice, and you will know the rounding when it comes to the final exam. So that is number 91. That is how you find the standard deviation by hand for single data. Now, suppose if you want to find the standard deviation for this single data in your graphing calculator, your TI-84, you can go to stats. You can go to edit the list. So let's edit. We're going to clear your list. So make sure to always clear the list. And inside of L1, you can put in your values. So 2, 3, 4, 5, 6. You're going to then hit stats. You're going to go over to calc. One variable statistics again. There's no frequency list in this case, so you can leave it blank, or you can still put L2. Doesn't really make a difference. So second and 2. Well, list is empty, so I guess you can't do that. So just leave it blank. If you're not using L2, just leave L2 blank. Scroll up, and the one that says S sub x, this means standard deviation of the variable x. As you can see, 1.5811, and then so forth. So there you go. That is the way to calculate the standard deviation in the calculator. As what we can see, we are going to move on to question number 90. Now for number 90, I am still going to utilize the TI-84 calculator because you want to find the standard deviation for the group data set. For this question, I'm only going to find the midpoints of each class. You need to find the midpoints of each class. And we already found the midpoints for this group frequency distribution. At least I think we did. Because if we go back up to question number 84, we found the midpoints for these classes. The frequency is different for number 84, but we already found the midpoints. And once again, to find the midpoints, you're going to follow the midpoint formula for classes. Lower limit plus upper limit divided by 2. So maybe I'll just do one example just to show you. Then after that, I'm going to just fill in the rest. So to find the midpoint for the first class, that is 50 plus 59 divided by 2, which is 54.5. You're going to add first, then divide. Okay, so let's put in the rest. 64.5, 74.5, 84.5, 94.5. And now we're going to use our calculator again, and we're going to compute the standard deviation. Let's go to edit. Let's clear out our list 1. So you're going to hit clear. So let's put in some data values in. The midpoint should go into the list 1, L1. So that's going to be 54.5, 74.5, 94.5. Then you're going to use your arrow, go over to list number 2, and you're going to fill in the corresponding frequencies. So that's 5, 5, 9, 11, 10. Then you're going to go to stats, go to calculate, click one variable statistics, set your L2 to frequency list, hit enter. And once again, to find the sample standard deviation, your S sub x, which is the sample standard deviation, that is approximately 13.4. I'm going to use one number after the decimal in this case. If you're using a TI-30 or a TI-36, you can still find a standard deviation of the sample using those. So if you're using a TI-36, there is already a table option. You can just put in the data and then calculate the statistics. And if it's a TI-30 calculator, you're going to have to activate the stats variance mode. And then you'll be able to put in the midpoints and the frequencies. But that's more for like a in-person type of demo. Or you can just YouTube it. All right, guys, that is it for this video on standard deviations. I do urge you guys to understand how to compute the standard deviation by hand. and don't just rely on a calculator for your results. All right, guys, take care.